Yeah, just starting off here.
I think I've changed my idea about this presentation. Um, Originally, Ken and I were talking about the application of system dynamics, and after discussing this offline with John Burtis, I decided to not do my presentation on system dynamics, but do my presentation on AI's use of the SEBoK. So I hope people don't mind that change of direction. Also, too, John and I were talking about the use of AI for resilience and for loss-driven engineering. John has done a really good paper, I think, using Grok. I use ChatGPT and John's paper, I think, is much better than mine, but I know I was committed to present, so this is what I'm presenting. Anyways, the title is European Resilience to Gray Zone Sabotage. And this is important because you can see from this picture that gray zone sabotage has been increasing quite substantially. At least it did in 2024, and 2020. This data is only up until July 2025, so it may not be completely up to date. So, and you can see here the different targets that the gray zone sabotage is targeting, uh, and uh, uh, and underwater is in blue there, dark blue there. Undersea and water is in blue here, and that's the focus of John Burtis's work. So I think his work is very important, and hopefully, John, you can present that at some point in the future. Okay, so then the other idea is there's a picture of where the sabotage is occurring across Europe, and you can see that it's scattered basically all over Europe, according to this research. And so it's not isolated to any particular place. So, anyways, that's another point of reference. So, the purpose of this briefing is to provide a systems engineering and resilience perspective on European exposure to gray zone sabotage. And we want to translate the qualitative reporting on gray zone sabotage into a structured, defensible, and resilience actions. And we want to ground the recommendations explicitly in the SEBoK and the Resilience Systems Working Group taxonomy. And we want to focus attention on where limited resources produce the greatest leverage. And the framing of the question is, how does Europe systematically reduce the payoff of gray zone sabotage without escalation or unrealistic assumptions about attribution? So the methodology was basically, as I said, I used ChatGPT, and so I was thinking this might be interesting to our discussion of how we can use AI in resilience work. So it's all based on ChatGPT queries, and what I did was I gave it 5 articles from The Economist. And these were just like, news articles. And then I gave it the taxonomy from the SEBoK. And then I asked it for the highest return on investment based responses to this sabotage. And then I asked it to translate that into policy and metrics. So that was the process. Okay, so John asked this, when I showed this to John Burtis, he asked, well, how do you calculate return on investment here? And so this is what ChatGPT came up with. So we want a reduction in attacker payoff and system disruption per unit of cost and friction. So high ROI actions score well on speed. It acts fast when an attacker faster than the attacker's decision cycle. The incentives reduce payoff or imposes immediate cost. It's leverage, so it limits cascading results and affects multiple resilience layers. And sustainability, it's maintainable over years and not weeks. It's feasible, works within legal, political, and alliance constraints. And the rule of thumb here is that we want to change system behavior, not eliminate every incident.
So here's the result sabotage problem.
Is, as we saw in those graphs, we have increasing low-level ambiguous attacks on civilian infrastructure. And the targets include undersea cables, power interconnectors, logistics hubs, GPS. And the effects are psychological and political, not primarily physical. And the key feature is plausible deniability and slow attribution, which favor the attacker. So the evidence base and the source material, as I said, it's based on these 5 articles from The Economist between 2024 and 2026. And those articles are based on a report that was generated by some kind of a tracking organization. I don't think it was NATO. It might have been European Union. Okay, and the documented cases, as I said, are undersea cable disruptions in the Baltics, dark fleet operations and proxy actors, cyber and hybrid interference, and the common patterns identified are high ambiguity of intent, civilian and privately owned infrastructure, and disproportionate political and psychological impact. So this is why traditional responses fall short. The common default responses demand high confidence attribution. They could require increased patrols and surveillance everywhere. They threaten escalation or sanctions after the fact. And why these underperform is attribution is slow, contested, and legally fragile. Continuous patrols are expensive and unsustainable, and escalation risks alliance fragmentation. So the key system insight is deterrence fails when response latency exceeds the attacker's decision cycle. So the systems engineering framing is resilience, not protection. So we reframe sabotage as a stress on a capability delivery, not a failure of individual assets. We're going to use the SEBoK and the taxonomy. And the idea is we're going to, of course, use the avoid to reduce the probability that the adversity becomes stress. We're going to withstand by limiting degradation when stress occurs. And we're going to avoid by restoring or forward recovery capability rapidly. And the strategic objective is change the system conditions so sabotage is low impact, short-lived, and unattractive. Okay, under avoid, we want to eliminate or reduce exposure to stress before it hits. And from the SEBoK's point of view, this means anticipate and understand, monitor and detect, and prevent and reduce vulnerability, manage complexities, and disaggregate. So avoidance is about probability reduction, not perfect prevention. So here's the high ROI actions, rapid detection, and decisive interdiction. So what this means operationally, we have persistent monitoring of high-risk corridors and choke points. We have fused sensing, automated identification system behavior, loitering anchor, patterns, and anchor anomalies. And we have pre-authorized legal and operational authority to board, divert, detain vessels when sabotage relevant indicators appear. And this is primarily, I think, for the undersea cables sabotage in the Baltics. And why speed dominates is gray zone tactics exploit hesitation or not ignorance, and immediate consequence collapses plausible deniability. The bottom line is that speed matters more than certainty. And why is this high ROI? High impact on incentives, collapses deniability. It's fast acting. It's cheaper than blanket protection. It uses existing Coast Guard and port state authorities. And now we'll get into withstand. So now we'll get into withstand, resist capability degradation. So we want to keep the required capability above minimum thresholds under stress. And from the SEBoK's point of view, this means constrain propagation, continue operation, degrade gracefully, preserve integrity. And this shifts the focus from assets to service continuity. And the high ROI action here is graceful degradation by design. And what this means is we segment networks to prevent cascading failures. We prioritize critical traffic, defense, emergency, and grid control. We define degraded but useful operation modes. And why this dominates. Sabotage fails strategically if disruption is contained. Political impact depends on visible failure, not technical damage. And the bottom line is if disruption doesn't cascade, the strategy fails. And why this is high ROI. It dramatically reduces the strategic payoff of attacks. It's a one-time architectural investment for a long life, with a long life. It reduces both technical and political disruption. And now we'll get into recover. So we want to replenish lost capability quickly. So the idea is restore or forward recover capability after degradation. So from a SEBoK point of view, this means repair and maintain, replace and substitute, redeploy resources, and adapt and evolve. So we want recovery speed determines political and psychological impact. So the high ROI here is pre-positioned repair and substitution. And what this means is we have standing contracts for repair vessels, crews, and spares. And we have a pre-planned substitution paths for rerouting, temporary capacity procurement, and satellite backhaul. And we have cross-border mutual aid agreements. And why this dominates is fast recovery reframes sabotage as routine maintenance, cheaper than universal redundancy. And the bottom line is if recovery is boring, intimidation stops working. And why this is high ROI is it directly shortens the disruption duration. It converts crisis into routine events. It avoids overbuilding redundancy everywhere. Okay, so now we have this idea of a 80-20 resilience strategy. And if Europe does only three things, it acts fast, not perfectly, so it avoids. Fails quickly, not catastrophically, so it withstands. And it recover faster than the news cycle, that's the recover. And everything else just supports these three. So measuring what matters. So I asked ChatGPT, how are we going to measure this? And it came up with the idea is that resilience must be measurable, governable, and comparable. And the key metric categories are detection speed, time to classify anomaly, response speed, time to interdict where lawful, architectural resilience, segmentation, compliance, operational performance, service continuity, recovery performance, time to minimum capability. And the principle here is measure what changes attackers' incentives, not what is easiest to count. So the key takeaways from the Resilient Systems Working Group is that gray zone sabotage is a systems problem. Perfect prevention is unrealistic and unnecessary. Resilience shifts incentives without escalation. And the strategic message is design systems so sabotage is ineffective, unprofitable, and boring. So basically, I guess really from the takeaway from the point of view of the Resilient Systems Working Group is that we can use AI with the taxonomy to come up with resilience solutions to real life problems. And however, I think the issue with this presentation is the resilience actions are primarily policy and political oriented. And that's where I think maybe, John, you can describe your work where John was actually working on design of resilience in the same basic problem space. Okay, so my final thought is the ability to see the whole is more valuable than the mastery of the parts, and I'm open for questions. Thank you for your attention.